Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x plus 3 to the power of x is equal to 5. So we want to find the value of x. So now for our solution here, we have 3 to the power of x plus 3 to the power of x is equal to 5. And now the first thing I'm going to do is from our left-hand side here, I'm going to factor out 3 to the power of x. So I have 3 to the power of x now times, now 3 to the power of x divided by 3 to the power of x, that is equal to 1. So I have 1 plus, again, 3 to the power of x divided by 3 to the power of x, that is 1. So now I have 3 to the power of x times 1 plus 1 is equal to 5. Now 1 plus 1 here, this is equal to 2. So now I have 3 to the power of x times 2 is equal to 5. Now what I'm going to do is I'm going to divide both sides by 2. So then these two would cancel out, and I would be left with 3 to the power of x is equal to 5 over 2. Now, an important property of logarithms is that if I take the log of, let's say, a to the power of b, I can actually move this exponent b to the front of the logarithm. So then this would be equal b times log a. So what I'm going to do with this equation is I'm going to first take the log on both sides. So now I have log of 3 to the power of x is equal to log of 5 over 2. And now using this property, if I have log a to the power of b, this is equal to, and move this exponent, b times log a. And actually, an important use of this property is, let's say we have 7 to the power of x, right? And this is equal to 9. We can actually, if we first take the log on both sides, we have log 7 to the power of x is equal to log 9. Then we can use this property, and this property, by the way, is known as the power property. So then we can use this property and we can move this x here to the front. So then we get x times log 7 is equal to log 9. Now we can divide both sides by log 7, and then we get x, these two cancel out, is equal to log 9 over log 7. So this property actually changed this x from an exponent to an actual term. So that's the great thing about this property. It changes an exponent to a real term. So then if you want to solve for x, you can't really do it at the current form it's in. So then you could turn it into an actual term and then solve for it. So now going back to our original problem, we had 3 to the power of x is equal to 5 over 2. So then if I take the log of this on both sides, I get log 3 to the power of x is equal to log 5 over 2. And then using that property, I can now move my x to the front. So now I get x times log 3 is equal to log 5 over 2. And now log, this is the same thing as log base 10. But the reason we don't write the 10 is because there's no use, because if I have log base 10 of 3 is equal to a number, right? This is simply saying 10 to the power of x is equal to 3. So we usually don't really need to write the log 10 because it's the same thing as just normal log. So now we have x base 10 of x times log base 10 of 3 is equal to log base 10 of 5 over 2. And now another property of logarithms is that if I have a log of a over b, this is actually equal to log a minus log b. So log 5 over 2, as you see here, this, in this case, this is a equals 5 and b equals 2. This would equal log a, so log 5, minus log b, so log 2. So now what I'm going to do is I'm going to divide both sides by log 3. So then these two cancel out, and I would be left with x is equal to log 5 minus log 2 over log 3. So now log 5, this is equal to approximately 0.6990. Log 2, this is equal to approximately 0.3010. And now finally, log 3, this is equal to approximately 0.4771. So now if I plug these values into my original equation, which was x is equal to log 5 minus log 2 over log 3, well, log 5 here, this is equal to 0.6990, so I get 0.6990 minus log 2, which was equal to 0.3010, so 0.3010 all over log 3. And now log 3, this is equal to 0.4771, so 0.4771. So now x is equal to, now 0.6990 minus 0.3010, that is going to equal 0.698. And then I'm dividing this by 0.4771. So now if I divide these two, I get x is equal to 0.8342. So that is my answer. Now, to check, I had 3 to the power of x plus 3 to the power of x is equal to 5 for my original equation. Now, remember, x is equal to 0.8342. So now I have 3 to the power of 0.8342 plus 3 to the power of 0.8342 is equal to 5. Now 3 to the power of 0.8342, this is equal to approximately 2.5. So I have 2.5 plus 2.5 is equal to 5. And 2.5 plus 2.5 is 5. So I have 5 is equal to 5, and this is right. So the value of x is right as well. So QED. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 7 to the power of x is equal to 70. Now we can first start by converting 70 to 7 times 10. So now we have 7 to the power of x is equal to 7 times 10. Now I'm going to divide by 7 on both sides. So now we have 7 to the power of x over 7 is equal to, these two cancel out, so simply just 10. Now, if we have something in the form a to the power of m over a to the power of n, this is simply equal to a to the power of m minus n. So 7 to the power of x over 7, this would be 7 to the power of x minus 1. And now this is equal to 10. So now what we're going to do is we're going to take the log of both sides. So now we have log 7 to the power of x minus 1 is equal to log 10. Now, the power property of logarithm states that I can actually move this exponent here to the front of the log. So now this would be x minus 1 log 7 is equal to log 10. Now I'm going to divide both sides by log 7. So now these two cancel out, and I get x minus 1 is equal to log 10 over log 7. Now, if I add 1 on both sides, I get x is equal to 1 plus log 10 over log 7. So this is our answer.